Morgan and John, thanks very much for joining us today. Before we go into our discussion, I just want to say a little bit of background. So this session is hosted by Fluor, which is a global contracting firm, design build firm, very familiar, I'm sure, with everyone on who's joining us, but also a world leader in the carbon capture and storage space. In fact, Fluor is now working on delivering the world's largest CCS project in the Dakotas in the United States, and also designed and built the Quest project in Alberta. So as you join the event, I kindly ask that you keep your microphone on mute. Once we're finished with the discussion and we get to the Q&A component of the session, when people can start a little bit more interactive and asking questions and that type of thing, kindly ask that you either use the chat function if you have a comment or a question, or raise your hand. And that way I'll moderate the discussion and bring people in as need be. So with that, why don't we get started? So we have with us John Isley, who's Director of Process Technology at Fluor Canada, and Morgan Rodwell, who's Senior Director of Process Technology, also at Fluor Canada. For the layperson out there, best I can gather, process technology essentially means we're joined by two really clever engineers. Between the two of them, they have over 40 years of experience. You can find their bios in the speaker section of the website if you'd like further background. So let's get started. John, let's start with you. Well, there's a move, we heard this today in the earlier parts of the discussion with regard at the conference. There's a move away from hydrogen or hydrocarbon-based energy sources. The reality is they remain central to our economies and will for some time to come. Can you maybe tell us a little bit about how CCS and the supporting infrastructure will be central to managing the broader process of energy transition and for dealing with carbon?
Sure. Yeah. Well, first off, thank you for having me on board, and it's great to have this discussion with you. And look forward to bringing others in as we can expand this. So, but the reality, fossil fuels and hydrocarbon in general, they're a key part of our economy. They're a big part of our way of life, and as important as our aspirations are moving forward, we still must take advantage and be careful about this energy transition so we don't cripple ourselves. And it's not just energy and transportation, it's also chemicals and industrial household products. So the oil and gas sector is a pillar of the Canadian economy, of our jobs, and we have one of the world's largest resources. So, from this perspective and from our aspirations of the energy transition, we have the opportunity to be a world leader in the solutions moving toward this transition. And this is where carbon capture can come in, especially when considering this existing infrastructure that we have in place for production and manufacturing and export of our energy resources. So carbon capture offers us a way to reduce our carbon footprint while at the same time leveraging this infrastructure. Importantly, it's technically feasible, and with the right drivers in place, the threshold to incentivize for carbon capture is not that far off. So we have this opportunity to lead, and we can export not just our resources, but our technology solutions. Now, with respect to CCS, we have a fantastic start already. In Alberta and Saskatchewan, there are 4 large commercial scale carbon capture facilities in operation today. And there are numerous demonstration plants of both conventional and developing technologies. And there's strong support by the government and industry in R&D in this space. One of the enabling items are the CO2 pipeline hubs that are taking shape in the oil and gas producing regions. This is the Alberta Carbon Trunk Line, and there's an existing carbon sequestration in Weyburn, Saskatchewan. Western Canada has geology favorable for CO2 sequestration. So we're seeing several companies pursue these strategies, and it's not just in oil and gas, but in power, especially from coal, cement, and other process industries. So, the hesitation moving forward, and one of the reasons this hasn't just taken off is that some of the economic drivers are unclear. I mean, even though the government has announced the increase in carbon tax, at some point there needs to be kind of an inflection point where the drivers and the regulations that are that are put in place starts to create incentives and certainty for businesses to spend the capital needed for carbon capture and to move forward with their plan. So at some point, this is going to make a lot of sense. It's just a matter of time to see when that inflection point will occur. I see you talking, Jason, but I don't hear you.
My God. I mean, we've been doing this for a year and still, it never ends, does it? I mean, I thought we were going to get through this whole thing without somebody screwing up. And of course, it has to be me, right? So, so thanks for that, John. Morgan, let's turn over to you. Clearly for CCS, the regulatory framework is very important. Can you tell us a little bit about how regulatory uncertainty in Canada is making it challenging to roll out CCS technology at scale, and maybe some thoughts on some changes that could make the technology more viable?
I think that one of the issues is was brought up by Annette in the prior seminar about interprovincial differences and the lack of coordination across the country, and the question of exactly what is the carbon tax, what does it apply to, and who's actually going to pay it or try to avoid it through things like CCS. And even if you look at it, for example, Alberta's output-based emissions reduction system, the challenge is that it's all based on a benchmark, and if you're over the benchmark, you would end up paying the tax, and if you're under the benchmark, maybe you can sell a credit. But what are those credits worth? The open market will set that allowance, but it makes it difficult for companies to necessarily have certainty on what the valuation of that carbon would be. And more importantly, what is it, can you sell those credits outside the jurisdiction? Can you if you put CCS on to bring your plant in Alberta below the benchmark and generate a credit, can you sell that credit to somebody in Quebec, for instance, or are you stuck selling that credit in Alberta? And there's still some uncertainty, and the customers we talk to, that's one of the things that's a bit of a trigger to understand is, and as John said, the inflection point of when do we get to a point where I know what the economics look like to justify the capital investment for CCS. We're getting the technology is improving. Project execution is improving. We're getting down to a point where we think we know where that dollar per ton, it's going to break even. But it's still a question of how am I going to use those? How am I going to actually put those credits into my cash flow? How does that actually turn into the bottom line for the company? So that's one of the challenges. And it's very easy for somebody to say, well, yeah, but the carbon tax is X dollars a ton. But when you look at the output-based pricing systems, it's not quite that simple. And because it's now different from one province to the next, and then there's the provinces that don't have a system, so the federal backstop kicks in. It becomes a little bit confusing, and it would be extremely helpful if the provinces and the feds could get together and come up with a consistent set of rules. The other part of it is that there's even from the federal government, there's more than one set of rules and opportunities. So, there's the basic carbon tax and greenhouse gas pricing structure, but then we also have the clean fuel standard that's being drafted that will create other credits related to, that you could use carbon capture and sequestration for to generate those credits, but it only applies to the end fuels that are used in Canada. So if you are exporting crude oil, for instance, or exporting diesel fuel from Canada to the rest of the world, then those CCS on those types of things wouldn't generate a clean fuel credit. but they might generate one in the greenhouse gas pricing structure. So that's again where there seems to be some confusion over exactly how is this going to get priced and what's the confidence of turning it into bottom line money.
Great, thanks for that, Morgan. Just a reminder to everyone, if you can just kindly turn your video and your microphone, put your microphone on mute just for the time being. We have about 125 participants with us right now. So once we get to the open discussion, we can start engaging in that way. So I'd like to go with one more round of questions before I've got a couple have come in, but basically, Morgan, I'm going to go back to you again. As governments attempt to achieve a target of net zero emissions by 2050, can you tell us a little bit about how mature CCS technologies stack up against some of the more speculative technologies that are being promised as solutions to emissions reductions? I mean, as we've sort of gone down this path towards net zero 2050, there's all kinds of technologies that are being promoted out there. And CCS seems like it's been around for a while and offers a pretty viable pathway, especially for decarbonizing the fossil sector. So maybe you could just tell us a little about that, as how it stacks up.
Thanks. I think one of the things that's important to understand about CCS technologies is that some of it has been around for a very long time. Some of the technologies are based on processes that have been used in natural gas processing for nearly 100 years. And so those technologies, there's a lot of mature knowledge about how to do that. Our company's been involved with flue gas carbon capture for over 30 years, and so that technology is very mature. There have been many plants built, most of them at smaller scales. I mean, it started off as a business primarily for capturing CO2 for the food industry, but so those technologies exist, and today there's a handful of technologies that are commercially proven at scale to capture CO2 either from a hydrogen plant or other process plant, or from flue gas from power plants. And as you mentioned, we're currently engineering a project in the Dakotas that is doing carbon capture from flue gas. The challenge is that there's also a lot of these, as you say, new technologies that are out there, and some of them look really cool. The problem is what's their technology readiness level? When are they going to actually be ready for commercial implementation? I mean, it's not to say we shouldn't be spending money and effort on trying to make those work, but 2050 is not that far away. The idea of what's the targets we have to hit by 2030 and what do we have to have in place to get towards a net zero in 2050, we have to start building big infrastructure sooner than later. And waiting for technologies that might not be commercially ready until the mid 2030s probably isn't going to be the right path. One of the reports that I read recently from the it was the Canada's Net Zero Future by the Canadian Institute for Climate Choices. They talked about a lot of technologies that they called wildcards that they think we're going to have to depend on to get to these net zero things. But those wildcards are exactly some of these technologies that may not pan out or may take longer than a lot of people want them to take. A lot of these technologies, especially when you look at scale, it's not like you're going to do this at a lab and do it in a pilot scale this year and have a commercial plant next year. You'll be lucky if you have a commercial plant 5 or 10 years from now, if you're still on the lab scale today. So it's a challenge that has to be overcome, and that's why I think that some of the key things that if we're going to talk about getting to net zero, the technologies that we have today in carbon capture and storage, we need to rely on those today and get those kinds of things, that technology built, because it's not a dead end. There's technology there that it's got decades of experience, but there's still opportunities to make it better. But more operating experience is one of the things that helps make that better. So I think that's a key step that needs to happen.
Yeah, that's a very interesting point. I mentioned when I opened the conference this morning that at the Energy Roundtable we also do policy dialogues, at high level policy dialogues, including in the lead up to the COP meetings. And as we talk about these net zero by 2050 targets, is exactly to your point. it's not that far away. And if you're really going to achieve those targets, you need by 2030 basically to have placed your bets and to really start scaling up. As you say, to wait till 2035, it's probably going to be too late. So it will be interesting to see how this all plays out. But I think technological reality, as you say, is going to be the thing that dictates this in the end, and political expediency, I suppose, as well. John, just before I take some questions from the floor here, can you just maybe follow up on Morgan's comments and say a few words about Canada's competitive advantage when it comes to deploying CCS technology? I mean, we have an interesting geology, obviously, in the Western Sedimentary Basin. Seems to make sense for CCS technology. And we also have an interesting carbon infrastructure. But I guess we also have our limitations as well in different parts of the country. So maybe you could say a little bit about that.
Sure. Yeah. Part of the competitive advantage in Canada, it's been foreseen going back 15 years or so by the regulatory Canadian governments, the Alberta government, Saskatchewan governments made huge investments in CCS, and those demonstration projects today are operational. And this goes, I mentioned the four, but there's the other aspect of it is it includes various spectrum of different carbon capture technologies, different solvents, different methods, different processes. So there's post-combustion coal-fired power plant capture in Saskatchewan. There's pre-combustion, both in gasification and hydrogen SMR in Alberta. There's a fertilizer plant, and there's a pipeline, that infrastructure in place, which has significant capacity available. As well, on top of that is the sequestration side, the geology you mentioned. So it's scanning through. It turns out, of course, if you follow this field, that, and you would know that the geology where oil and gas is typically produced is also typically very good for sequestration, given the right conditions. But those conditions typically exist with the appropriate cap layers. And we're getting years and years of experience on that sequestration side. So the monitoring, the handling of the CO2 in its phase, which has its own challenges and its own hazards, but we've taken advantage of a learning curve that started a number of years ago. So on that base infrastructure standpoint, Canada can be considered a world leader. And as we see the other parts of the world embracing, whether it's the Paris Accords or their own internal goals of net zero by 2050, 2060, however that looks like, we have this huge knowledge base. And that, to me, is a business opportunity for all of us that follow that sector. Because, the reality is that Canada emissions, and for that matter, oil and gas production, is a drop in the bucket compared to what the rest of the world is doing. So we need to lead by example, in my opinion, on this, and I think we're doing so. It seems that the awareness and that knowledge base is not as widespread, and maybe it's just when you get outside of certain circles. But when we talk to the general public, or when we listen to the general public, it seems, let's just take the more extreme approach and come up with a total radical effect. But the reality is we have got such a long way to go. And it's like all we can do is take those first steps, but realize to the public, realize to the world that we've already taken those, that we're already headed in that vector, and to advertise that and to let people know that. And then we need to also take advantage and continue to turn that into more industrial, widespread hub type programs, which I think we're doing. It's taking some time. But as we said, just some of the certainty, some of the clarity of those drivers to get the capital moving in that direction.
It's like they say, everything old becomes new again. I remember, when we were running these conferences back in 2006, 2007, we talked a lot about CCS or CCUS, and yeah, here we are. At this point, what